information services that can be put together in a consolidated way to be used to address real industrial needs. When the project started, we had a vision what we wanted to achieve, and as you can see on the slide, the first two ambitions were really industry-driven and did not have an IT objective by themselves. So the first vision element was that we wanted to deliver awareness, we call it now situational awareness, throughout the supply chain in order to solve problems of data fragmentation, data delay, and inconsistency. Because if you see many supply chains nowadays, where the execution of the supply chain, although it is coordinated in the end by one party, is in the execution phase done by multiple parties, then there is a very limited amount of data that is being exchanged between them, especially if we want to achieve end-to-end visibility. Second point is we wanted to pick up data from every possible segment in the supply chain in order to provide accurate logistics information. That means that also information that originates at the early part of the supply chain can be relevant for the end part of the supply chain. So the end part of the supply chain is not depending on information that is provided to it by the party that delivers cargo to it. You can already start using information that originates at the early part of the supply chain. And then in order to deliver information that achieves these objectives, we wanted to create information services that are really usable and really affordable. And that's what I'm going to clarify. I'm going to use a few slides in order to explain the architectural vision that is underlying the CONSUS project. And first you see on top that our end goal is to create value-added services. Value-added services that help supply chains to be delivered timely and to be delivered at less cost. Let me make a side remark here. Information services themselves are not causing such savings in isolation. It is the way that they are being used by operational people in the real business. And the combination of the two, with information services and using them in a very proactive way, that actually can deliver that kind of value. But if value-added services, for example in the area of visibility, if they want to function, they need data. They need to source data throughout the supply chain. Now, if you look at the lower part of the figure, there you see a visual presentation of a physical process, where on the left side, a truck is doing pre-carriage from the consignor towards the port of loading. There is a terminal where activities are taking place, where the containers are being loaded into an ocean vessel. The ocean vessel is traveling towards a port of discharge, and in this case the train is doing on carriage from the seaport towards an inland destination. And obviously all of these segments are using their own IT systems, and all of these segments are able to generate information. What kind of information are we talking about? On the left side we start with container data. For a limited amount of containers, they can be equipped with tracking devices. We call them with a nice name, container security or container monitoring devices, which are able to track the movement of the container throughout the supply chain. Can create information both about position, but also about cargo condition and about security status. Next you see that the terminals, in this example, sea terminals for both the starting port and the ending port, are a source of data also. What kind of data are we looking into? Data that describes the gate in of the container to the terminal, or the gate out on the other side. Data that describes a loading operation or a discharge operation from a container to a vessel, or from a vessel to the terminal itself. timetables, etc. But they are also providing execution data. What is the expected time that a container will depart from the port? What is the expected time that it will depart? What are actual times? Where are transshipment events taking place? Especially transshipment events are extremely important in order to do a proactive control of the supply chain. Now, I just identified a few coming out of this physical process. But what we see is that these data are using all their own proprietary formats. There's nothing standardized. So in case you are developing value-added services in the area of end-to-end visibility, for example, and you want to use that information, you have to build proprietary interfaces. Now this is where the so-called common framework comes into play. So what we experimented with is how can you use the data that originates from the physical supply chain, and how can you first transform those data in standardized interfaces using the common framework. And by doing that, you are making the value-added services much easier because they can tap into standardized interfaces. That has led to a so-called three-layer architecture, where you distinguish the data aggregation layer, the data standardization layer, and the data consolidation layer. We'll try to explain what we mean by all the three of them. With the data aggregation layer, we are not talking so much about standards. We are talking about providing access to a lot of information. And let me maybe clarify that by picking out one example. In this case, I would like to pick out the example of SIGIS. SIGIS was a system that resulted from an earlier EU project called Integrity, and SIGIS provided access to terminal events for a lot of terminals. Now, those were both sea terminals, but also a bunch of inland terminals. In this case, those terminals were all within one terminal operator group, the Hutchinson group, but anyhow, it represented many different terminals within that group. SIGIS functioned as an aggregation point, as a data aggregation point. You can go to SIGIS and then ask for terminal events, not for a specific, not only for a specific terminal, but for many of them. And you can imagine that makes it much easier to get access to information. There are other data aggregation points that we have been using in concepts from the start. So we have been using an aggregation point where we got access to AIS information for multiple suppliers. We had an aggregation point where we could get access to container tracking device information. And there was also aggregation points that gave us ocean carrier information. On top of that, we envisioned a second layer, which is this data standardization layer. The data standardization layer picks up the data coming from these aggregation points, so huge amounts of data, and turns it into standardized formats, with as a result that value-added services which are implemented on top of that can really tap into the data in a standardized way. The kind of standards that we were using were differentiated a bit depending on which were the users of the data. In case we were developing value-added services for business use, we were using things like transport service description, transportation execution plan, and transportation status. For information that was supplied to customs authorities, we were speaking more about the common reporting schema. And as a short maybe break in the presentation, I would like to make a relation towards the iCargo presentation that Eric gave. In the iCargo presentation, you see a very, let's say, systematic, fundamental way of making that information available to all related players. What we are doing here is something which is a less fundamental nature, but really aimed at achieving results, value-added services for real problems on short term. So there's a little bit of time horizon difference between what we are doing here operation layer has access to all that information and tries to create more value from it by correlating data to each other. For example, in the business-to-business area, there we worked on this end-to-end visibility using the Local for C services platform, and we were combining all the information that originated from the bottom and in a business sense used it in order to detect what is the current status of the supply chain, what are impacts on the remaining part of the supply chain, etc. And we did a similar thing, but then in a prototyping environment in a business to administration demonstration. You can apply this in a wide variety of settings. So in the COMSYS project, we applied that in 2 typical settings. One setting was an end-to-end supply chain operated by DGL Global Forwarding. The second was a more limited setting, which was not focusing on one supply chain, but on a cross-section point where many supply chains went through the port of discharge. There, the accent was more on aligning the sea and the interland operations and detecting mismatches between the two and trying to use that to enable the terminal operator, ECT, to do a better lead planning and align the sea and interland operations in a better way. Now, if I just pick out the highlights from the DHL story that actually used this setup in order to address real business needs, then what was the business need that DHL had? The business need was that they wanted to raise the predictability of ocean freight. Now I can give a very standard talk about what is important about that predictability, but I will now zoom into one specific example that we have experienced in the project that's been very vital, and that's the issue of transshipments. For an ocean freight company, it happens quite a lot that a container, which is on full sea, is suddenly shipped into another vessel, and actually the freight forwarder does not know it. And what is happening then is that only after many days he detects that at the transshipment port the container was not loaded in time because there are priorities, and as a result there are delays which have knock-on effects to the rest of the supply chain. So part of the implementation that was done is to really grasp all the information we could get from ocean transporters in order to detect where transshipments took place, where they were going to take place, so to already know that beforehand. And as a result of that, create better sensitivity on the side of DHL to be aware when transshipments were going to take place and to anticipate on beforehand when there was a risk that these transshipments would cause a delay. So that was really a method of proactively trying to improve the performance of their ocean transportation. So what we did is we collected those informations, made them available through these data aggregation points, standardized the data, and consolidated the data. That means making cross-links between all types of data and use that in order to build the most reliable and most complete picture of how the supply chain has been acting until a certain moment and what are the impacts to be expected on the yet planned part of it. But part of the project was also to deliver that kind of information in a very user-friendly way, so that it would be a very lightweight, web-based solution that DHL and the customers of DHL would use to have one holistic view on the supply chain itself. And obviously, it was all based on management by exception, so they were informed when specific deviations occurred, and they could then enter the dashboard and drill down to the detail that helped them understand where the problem was and what they could do about it. Now, if we look at how such information services then are composed, I've given one example on this picture, where you see on the left side all kinds of data sources coming from individual ocean carriers, from individual AAS providers, from individual CSD providers, individual rail operators, individual terminal operators. And what we see is that there are information service providers who are specialized in providing ocean-related data, or specialized in providing AAS data, or specialized in providing rail status data. All of these are emerging in the marketplace. So what we will, and those are by itself information services. What we are doing in Consus is we have been consolidating all that information in order to correlate the data to each other into one service platform, which was the Global Foresee Services platform, which then provides one holistic information product towards the end user, which in this business case was either the global forwarder or the shipper, which was his customer. Obviously, we also needed a direct link towards the global forwarder system, because we need to be aware what kind of shipment we need to track now. So the forwarder system has data about which shipment, which container, for which customer is going from where to where, etc. Now, what is important to take into account when we look at really bringing that kind of service in an operational setting is, first of all, you need to interoperate between these services. We used as much as possible these common framework messages in order to tap into the data that specialized information providers were giving us. To give one example, if we have an AAS aggregator, we have worked together with an AAS provider who is not providing AAS through its own antenna network, but who is a specialist in aggregating AAS data worldwide from various providers. They have to comply to these standards in order to collaborate with us. So they need to deliver these data according to the common framework standards in this case, which is a transport progress status. I would like to point to it that it was not always possible to stick literally to those common framework messages. I can give you one simple example. If you look at the data coming from an ocean data aggregator, we are using the so-called transportation status. But officially, the transportation status needs a reference to a booking, let's call it that way. But of course, this is now not the case. We don't have any information on booking. We only want to use the status information itself. So some adjustments to fit the situation at hand had to be. The second very important part is service management. So our end user will receive a service level agreement, which defines what kind of information he's getting and what are the performance criteria under which he is getting it. Obviously, it has to do with the availability of the service itself, but also with the time limits of the data. And that is absolutely key if you want to deliver that information in a real operational setting. But that means that we have to knock on those requirements towards specialized information providers. So if we can go back to the AAS aggregator over there, we need to establish an SLA with that provider so that it enables us to combine it with other informations and fulfill the SLA that we need to deliver to our customer. So there's some service management involved here. There's also pricing aspects involved here. So if people come to Consus and say, how can I use these services? Do I need to pay all these data sources? No, they just need to pay a consolidated service. But that obviously requires alignment between the different information service providers to achieve a pricing that makes it possible to deliver a product at a sufficiently low price that is outweighed by the benefits. And obviously, this transaction-based price that is then being executed, which is being paid by the user, should be sufficiently high to pay for data sources, to pay for the whole hosting infrastructure that you need to do, to pay for service management, for further product management, and so on. So what we have learned from this exercise is that obviously we have interoperability between IT systems, and that is very important. But there is more required in order to put together business-oriented information services. three things that are, for us, are very important is that the data sources that are delivered as an information service, they should bring data with sufficient added value, and they should be complementary. So sometimes if you have information about the movements of a vessel, that the information is completely useless if you don't have access to other information which informs you on which ship a container has been loaded. So the value of data of an individual information provider only gets its value in combination with other data. The second thing is that proper service management and enforcing proper KPIs and quality of information is of essence. And third, pricing that is being used by individual information providers should be realistic and flexible. And so if you take as an example AIS, satellite-based AIS, if you want to buy satellite-based AIS data, that requires sometimes still a considerable investment. So you need to enforce your data providers to go with you in a very flexible charging mechanism. And that also allows a consolidated information provider to implement services without too much working hard. You can read more about houses on the website. Please do so. Two stories, each other story and CP story are well documented there. But there's also recently two case studies that have been added, which you can download from the website, which give you a good insight on the business motivations of those two implementations. And the results that come out of the website. Thank you, and I'm open for questions.
I'm Eric, and I'm a project manager within my company, and I would like to start with a general remark. Nowadays, we as individuals have almost unlimited access to information via our computers or via our phone. Unfortunately, this is not the case for logistics systems yet. I will try to give you a view how the iCargo project is trying to change. And this presentation will focus on how to share this information between companies in, of course, a secure and controlled way. So the challenges are that we are trying to create an ecosystem, and this ecosystem should be open. Everybody who has interest must be able to join or leave. Connections must be set up easily. And while with these two requirements, we still want to have the security and control over our data. So that's a real challenge. This is an overview, a very popular high-level overview of the iCargo infrastructure. And what's interesting for business is that if you have your ERP system connected to the iCargo ecosystem, you want to communicate with other ERP systems or with external devices attached to your cargo or with the available truck that's on board. And the main principle is that we share the information through access point. So the access point is the single entry point to the iCargo ecosystem. We use something like logistic network awareness, which is a software component that enables you to link your box to a pallet, to a container, to a truck or a vessel automatically. And then sends the information to your ERP system, which means that if you only are aware of your box, you still can get your estimated time of arrival derived from the relative position of your box in a container and the container related to a truck. things that we developed last year was the link software module, the magical component that links all the individual business objects together. It's not so magical because it derives the information from shipping plans. So if you don't provide this kind of information, you do not get the link. Another interesting point of the iCargo concept is the concept of the semantic gateway. We introduced a unified, uniform interface specification to be used among the iCargo components. But if you have already implemented a particular standard, use one from the framework, and you would like to still use that, you can implement it with semantic gateway. It's a gateway plus to translate and transform your messages into something that the recipient can understand. But I do not want to focus on semantic gateway today. Because it's strongly related to the use of semantics and semantic models, domain models, which justifies a whole presentation on its own. Today I would like to focus on two things. How to set up a connection and how to specify which kind of information you would like to share. So what we came up with is an API. It's represented by the blue line at the top. And this API is a technical API. It doesn't specify the content of your messages, and it can use any message format you like. Whether it's you use one message with an XML format, or if you prefer JSON, it's possible. But you can also exchange binary information like PDF or images. This interface is also applicable between components, and basically it will make it indifferent for the user, for the logistic service providers, for the logistic services, indifferent which kind of technology is being used under the hood. So the grayed out part could be running at your mainframe, could be running at your laptop, or could be running in the cloud. And the main design driver was it can be an inhomogeneous environment. So someone can implement this stuff in COBOL, Java, C#, whatever. It's the interface specification that will tie everything together. So basically it means that your company, your ERP services, transport management services, represented as external services, talk with the rest of the world, or talk with your smart devices attached to your cargo or your truck through this interface, and get access to what we call the iCargo entity-centric IT infrastructure. And other companies do the same. So, in the previous slide, we raised the question, if I want to join, I need an access point. But basically, the first question you should ask is not how to get an access point, but how to use the iCargo ecosystem, the blue part, because then you can be part of the ecosystem. And within this ecosystem, at least 3 business applications will be provided by the iCargo project, but others can be attached as well. You can also attach your own software service on top. The linking in is the API definition. So that's one of the aspects that we try to achieve in iCargo. But there's something else. Technically, there are a lot of solutions to connect systems to each other. And I will not go into detail of that. But the second step is how to connect to each other. If you are a human, you are using Skype, you probably need to send an invitation, and if the other accepts, then you can set up a connection. iCargo will have a similar approach. iCargo will have a similar approach. So you are not exposed to the whole world, but you will set up connections very specific on an initiative from a requester and a confirmation of the inviter. So how does this work? For humans, this works well. For systems, we have to do a lot. And one of the things is that you have to configure a lot of things. And this type of configuration with a lot of screens and a lot of technical data, we would like to try to avoid. We would like to automate it and take it to a more functional or business level. So it should be as easy as configuring your phone. And how does this do so? What do I mean? If I have selected a partner to share information with, I also have to specify which type of information I would like to share, which can be actually kind of partial, which means if this information for a particular box concerning your partner could be made aware of it as soon as this information is available. So you can switch on a limited number, but business-related attributes, like the estimated time of arrival or the actual time of arrival. Or perhaps you also want to share the content of the goods or a description of the content. Could be useful for or mandatory for communication with customers. But perhaps not all your partners need to know that. It's up to you. And what we have foreseen is a concept, an electronic concept, an IT concept, where you can describe this not as a configuration, what technically it is, but at a functional level where you can easily switch on or switch off which data you want to share. So, how does this work? First, you will need a little description of yourself where you describe what type of company you are. You have to describe your business service descriptions and the description of the kind of business you can provide is can be used to find others. For instance, if you are a logistics service client, you can find a logistics service provider that can fulfill your needs. And we have a sort of component called the logistic chain composition, which acts like a small phone book. It displays the potential candidates you can do business with based on the type of cargo you want to transport. So after you have selected a company to cooperate with, the next thing that you need to do in our iCargo system is to set up a cooperation agreement. And the cooperation agreement is the profile, is the configuration where you state in one relation how you are going to communicate, what type of terminology you are going to use, your message formats, your message styles, and which data you would like to share. You do this once, and when done, you can start sending orders, exchanging orders, and do the execution of the transport. Transport the cargo. Last year, I already introduced the cooperation agreement as a location where you also can describe how to set which kind of emission calculations you want and how to share this kind of information with your partners. So basically, the cooperation agreement is the second iCargo concept that I would like to mention today, which is currently, well, I wouldn't say it's missing, but it's not a common approach for setting up connections. But we think that this concept can help us to set up connections between companies more easily and fast. So, to wrap up my presentation, iCargo is about an API-driven development. It's not about building access points. It's about defining the API, a unified API. And this enables other companies, but also other service providers to look on new services, logistic services, but perhaps also software services to enable collaborative planning or things like that. And the other concept is the cooperation. I think that API-driven development and the introduction of the cooperation agreement can lead to a disruptive innovation. Because it's not a challenge to catch you on the line, but to catch you on the line.